Welcome back to my channel. This is my third video on probability. If you have not watched the first two videos, please watch them and then come back here so that it will be easy for you to understand. It will be a continuity of the earlier two videos. Here we will start with the eighth problem. First seven problems are in my first two videos of probability. I will give the link in the description. Now we will start with the eighth problem. Eighth problem is a die is thrown at random. Find the probability of getting 2, a number less than 3, a composite number and a number not less than 4. So the first thing what we have to do is number of possible outcomes. Number of possible outcomes when we throw one die is 6. So what are the possible outcomes? 1, 2, 3, 4, 5 and 6. We have only these possibilities. So the number of possible outcomes is 6. So the first subdivision is a 2, getting a 2. The number 2 appears only once in a die, right? So the number 2 appears only once. It will not appear 2 time, 3 time and all. Therefore, the favorite outcomes, our favorite outcome in this is only one. Only 1, 2 in the die. Okay. So now, therefore, probability of getting the number 2. Probability of getting the number 2 is 1. 1 is our favorable outcome and how many possible outcomes? We have 6. So 1 divided by 6. Probability of getting the number 2 is 1 by 6. And now the second subdivision B. A number less than 3. A number less than 3. How many numbers? So we have totally 6 possibilities and in that how many numbers are less than 3? They are 1 and 2. They have not told less than or equal to. So 3 will not be included in this case. We have only 1 and 2 possibility. Okay. So the numbers less than 3. Numbers less than 3 are 1 and 2. Only these two. Therefore, our favorable outcomes, that is, how many numbers are there? Favorable outcomes. Favorite outcome I wrote. Favorable outcomes are, number of favorable outcomes are 2. Therefore, probability of getting a number less than 3 is equal to 2 divided by 6. That is, 2 is our favorable outcome and 6 is the total possible outcome. But we cannot represent 2 by 6 in a probability. We have to reduce it and make it 1 by 3. So, a number less than 3 is, the probability of getting a number less than 3 is 1 by 3. And now, the C1 is a composite number. A composite number. First, we have to know what is composite number and what is prime number. What are the possible outcomes? 1, 2, 3, 4, 5 and 6. We have these many outcomes possible when we throw a die. In that, this number 1 is there. No, it is not a prime and not a composite number. It is not anything. It is not a prime, not a composite number. Prime number means it has no other divisors. It will be divided by only 1 and by itself. But we will not consider 1, the number 1 as prime or composite. It's neither a prime nor a composite. And 2 and 3 are prime numbers. And 4 and 6, these two are composite numbers. Whereas 5 is again a prime number. 1 is not a prime not a composite. It is not anything. So how many composite numbers we have? We have 4 and 6. Only two numbers in this. When you throw one die, we will have only two composite numbers and they are 4 and 6. If you take something like prime number also, one will not appear. Please remember this. Okay, now composite numbers we have found out. So how many? So what are the composite numbers we have? Composite numbers are 4 and 6. We have only these two. So number of composite numbers. Number of composite numbers is equal to two numbers we have. Therefore, probability of getting composite numbers is equal to 2 by 6. 2 is our favorable outcome and 6 is the total possible outcome. When you reduce, it will become 1 by 3. So again, in this case also it is 1 by 3 only. The fourth one is a number not less than 4. A number not less than 4 is equal to greater than or equal to 4. That is the meaning. A number, it is not less than 4 means it is greater than 4 and equal to also. Equal to 4 is also not less, right? So, greater than or equal to 4. So, what are the such numbers? Numbers not less than 4. So, that will be equivalent to, what are the numbers possible? 4, 5 and 6. See, here 5 and 6 are greater than 4. So, not less. It is not lesser than 4. And 4 is also not lesser than 4. It is equal to. So, that will also be included in this. Okay. So, therefore, the number of favorable outcomes. We'll write it that way. Okay. So, the number of favorable outcomes is equal to 3. 4, 5 and 6, 3. Okay. Therefore, probability of getting a number not less than 4 is equal to favorable outcome is 3 and the total possible outcome is 6. That means it is equivalent to 1 by 2. Please remember, not less than means 1, 2, 3 are all like coming in that way. But not less than means it is greater. And equal to will also come because equal number is also not lesser than that number, right? So, okay. The ninth problem is a box contains 19 balls bearing 1, 2, 3 till 19 numbers respectively. A ball is drawn at random from the box. Find the probability that the number on the ball is prime number, even number, number divisible by 3, all that. Okay. So now the first thing in this is, you know very well, we have to find out total number. All possible outcomes. So total number of balls. How many balls are there? We have 19 balls are there. So now first subdivision. A prime number. A prime number. Okay, so how many prime numbers are there in between that 1 to 19? So I will write that first. Prime numbers between this 1 and 19. 1 is not a prime, not a composite number. Leave it. 2 is a prime number. 3 is a prime number. 5, then 7, 11, 13, 17 and 19. These are the prime numbers possible between 1 and 19. So how many numbers we have? 1, 2, 3, 4, 5, 6, 7, 8. Therefore, number of prime numbers. Number of prime numbers. How many prime numbers we have? That is 8. Okay. So therefore, probability of getting a prime number. Probability of getting a prime number. That is equivalent to favorable cases. Our favorable cases is 8 divided by total possible outcomes is 19. Okay. So probability of getting a prime number is equivalent to 8 by 19 in this case. We'll do the second one. Second one is an even number. An even number. Okay, now again I will write the even numbers possible. Even numbers possible are 2, 4, 6, 8, 10, 12, 14, 16 and 18. We have these many even numbers between 1 and 19. So how many numbers you have? Number of even numbers. The number of even numbers is equal to 9 even numbers we have. Okay. And then therefore probability of getting an even number. Probability of getting a even number. Favorable outcome is 9 and total possible outcomes are 19. So in this case, getting a even number, the probability of getting a even number is 9 by 19. Now we will do the third subdivision. See, a number divisible by 3. Again we will write what are the numbers divisible by 3? 3, 6, 9, 12, 15 and 18. These are the numbers between 1 and 19 are divisible by 3. So how many numbers are there? Number of, okay, here I will write favorable outcomes. Favorable outcomes means what we want. We want number divisible by 3. How many are there? We have 6. 3, 6, 9, 12, 15 and 18. The number of favorable outcomes is 6. Therefore, probability of getting a number divisible by 3 is equal to favorable outcome is 6 divided by total possible outcome is 19. So, in this case, the probability is 6 by 19. The 10th question is, one card is drawn at random from a well-shuffled deck of 52 cards. Find the probability that the card drawn is a king, spade, red queen, black eight, all that. Now once again I will explain the card details. This is the playing cards. Okay. So I have already explained this in my first probability video, but still once again I'll explain. See, we have 52 playing cards and in that two sets are we call it suit, S-U-I-T, suit. So two suits are black and two suits are red and the black suits are spade and club and the red suits are diamond and heart and we have 13 cards each in each suit. So totally 4 suits, so totally 52 cards. And in each suit, we have one king, one queen, one jack, one ace and the numbered cards from 2 to 10. In that, we call some as face cards. Face cards means king, queen and jack. These 3 cards in each suit is called face cards. They have faces, no? King, queen, all that. So these are about the cards and in detail I have explained about these cards in my first probability video. Okay, now, so how many total number of cards? Total number of cards is 52. You need not draw this in the exam. This is for your explanation in this video. That's all. So now the first one is total number of cards. We have 52 total cards. Okay. And the first one is a king. They have asked you about king. So how many kings are there? You have 1, 2, 3 and 4 kings are there. Okay. So we have to collect the kings from all the suits. It is not mentioned one particular suit. So all the suits. Totally we have 4 kings in the 52 cards. So number of kings. Number of kings is equal to 4 and therefore probability of getting a king is 4 by 52. 52 is the total possible outcome and 4 is our favorable outcome. And when you reduce it, it will become 1 by 13. And the second subdivision. A spade. So how many spades are there? We have totally 13 spade cards are there. Here they have not discriminated any king, queen, number card, nothing. Spade cards. So we have 13 spade cards in the 52 cards. So now number of spades. How many spades we have? 13. So therefore probability of getting a spade. So favorable outcome is 13 divided by total possible outcome is 52, which is equivalent to 1 by 4. So this is the probability of getting a spade in the playing cards. And the next one, third one is a red queen. Yeah, red queen. Okay, so now again I'll go back to this thing and I'll show you. See, we have these diamond and heart are red, and in that here one queen is there and here one queen is there. So totally we have two red queens. Okay, so number of red queens, only red queens. Okay, so that is equivalent to 2. Therefore probability of getting a red queen is equal to 2 by 52. 2 is our favorable outcome and 52 is the total possible outcome. So it is equivalent to 1 by 26. Now the fourth subdivision, subdivision D. A black 8. Okay, again I'll show you in the figure. See, we have two black cards, spade and club, and we have two numbered cards here and here. So, 2 times 8 will appear. 1 8 will appear in spade and 1 8 will appear in club card also. So, we have 2 black 8. Now, how many black 8s are there? Number of black 8. How many black 8s? 2 we have. Therefore, probability of getting a black 8 is equal to 2 by 52, which is again equal to 1 by 26. Next problem is, one card is drawn at random from a well shuffled deck of 52 cards. Find the probability that the card drawn is 4, a queen, a black card. Okay, so now once again I have given this figure because for explanation only I am giving it. Don't write all this in the exam. Only the answer you write it in the exam. Okay, so it is again that deck of cards. So total number of possible outcomes. Okay, so total number of outcomes or total number of cards is equal to 52. We have 52 cards. Okay, and the first subdivision is 4. How many 4s you have? So here in this spade we have one in the spade we have one number card. Here club we have one number card, diamond and heart. So 4 4s are there. In spade we have 1 4, in club we have 1 4, in diamond and in heart each one will have 1 1 4. So total number of 4s. Total number of 4s. How many 4s? We have 4 4s. So therefore, probability of getting A4 is equal to 4 divided by 52. 4 is the favorable outcome, 52 is the total possible outcome. When you cancel, it will become 1 by 13. So this is the answer for getting a 4. Now second subdivision, a queen. Okay, so now again I'll go back here and I'll show you. We have how many queens? In spade we have 1 queen, in club we have 1 queen, in diamond we have 1 queen and in heart we have 1 queen. Totally we have 4 queens. Okay, So total number of queens. We have 4 queens. So therefore probability of getting a queen is equal to again 4 by 52, which is equivalent to 1 by 13. Now third subdivision. A black card. How many black cards are there? So we have spade and club. Totally 2 suits of black cards. Here 13 and here 13. That means totally we have 26 black cards. Spade and club are the black cards and we have 26 black cards. Spade 13 and club 13. Totally we have 26 black cards. So number of black cards is equal to 26. Therefore, probability of getting a black card is equal to favorable outcome is 26, total possible outcome is 52, which is equivalent to 1 by 2. Probability is very easy chapter. If you understand it properly, it is very easy for you to score full marks in the exam in probability chapter. If you like my videos, please like, share and subscribe. Thank you.